In this video, I'll show you how I designed, printed, and assembled a rocket for my Level 1 cert attempt. The rocket was designed to be printed in 4 main components: the lower airframe, middle airframe, upper airframe, and nose cone. The remaining parts such as the motor retainer and motor tube were sourced separately. Here we can see the various components laid out in OpenRocket with the respective weights and dimensions used to calculate the stability index. These values, along with motor configuration, were used to simulate the rocket's apogee. The motor configuration for this simulation used an Aerotech i300 reloadable motor with a total impulse of 436 Newton-seconds. I first start with assembling the lower airframe, sanding the motor tube, applying epoxy to secure the motor retainer, then spreading the remaining epoxy onto the motor tube. The motor tube is then inserted into the cavity within the lower airframe and left to cure. Next, I insert the eye bolt and heat inserts into the lower airframe. The eye bolt provides an anchor for the shock cord, and the heat inserts provide fastening locations for the rail buttons. I then add the heat inserts for securing the nose cone to the upper airframe. I then secure the shock cord to the eye bolt on the lower airframe and then pass it through the middle airframe. The middle airframe is then secured onto the lower airframe using M3 screws inserted into the heat inserts of the lower airframe. I tie an alpine butterfly knot before passing the shock cord through the upper airframe and securing it to the eye bolt of the nose cone using a bowline knot. I attach the chute protector and parachute on the shock cord using a quick link on the alpine butterfly knot. I then wrap the chute protector around the parachute and wrap the shock cord before seeing how they fit within the body tubes of the rocket. This is important, as we'll see later, as packing the parachute too tightly may prevent it from properly deploying. I then combine both the upper and lower portions of the rocket and secure the nose cone to the upper airframe using the same M3 screws as before. With this, the rocket is assembled and the only steps remaining are to add in the camera and prepare its motor for launch.
Good luck!
At the launch site, I assembled the motor and with Derek's help, placed the rocket onto the launch pad and set up the ignition charge. At this point, the rocket is primed and ready for launch.
Back continuity going in 5, 4, 3, 2, 1.
Holy.
How's it feel?
That was great. Dude, you have coffee?
Unfortunately, I forgot one critical step.
I have the blinking is not being currently recording. Could you read the instructions for the camera before this point?
Oh, we'll see.
We'll find
Shit.
out. Alright, launch it again.
It turns out that when I installed the camera to the rocket, I had only turned it on and forgotten to start recording, thus missing all the footage from this first launch. Fortunately, I was able to source a similar motor in order to attempt another launch. A big thank you to RJ, who not only provided me with a motor reload, but also lent me the casing for it as well. This motor was a Cesaroni 135 3-grain motor with a total impulse of 399 Newton-seconds. Its expected apogee was a bit lower than the first, but would still be enough to deploy the recovery devices properly. While we're waiting, I'll briefly go over my previous cert attempt. This rocket was a bit thinner and constructed using the same PETG filament and Creality Ender 5 Plus printer, with the excess material removed by turning it on a lathe. The components were then assembled and brought to LDRS 2023, where I then launched it, but did not clear my Level 1 certification due to the recovery devices failing to deploy. This is primarily because the inner diameter of the rocket was too small, requiring the parachute to be packed tightly in order to fit. As a result, the rocket hit the ground without a recovery device, breaking its fin and nose cone upon landing.
Oh, there it is. Yes. Yay!
You turn the camera on?
As we can see, the rocket was able to deploy its recovery devices properly, with the camera successfully recording the entire event. At this point, I'd already achieved my level 1 cert earlier that day, but was pushed by my friend Sadie to launch again in order to capture the footage. I'm glad I did so because there's nothing like seeing the launch from the point of view of the rocket. With this, I'd like to thank the following people, as without them none of this would be possible. Derek Rose, Dave Rose, Sadie Cook, Mark Lee, RJ Schubert, the members of Carnegie Mellon Rocket Command, and Tripoli Pittsburgh for letting me launch this 3D printed rocket. Thank you for watching, and bye.